Section 1(6), simplifying basic radicals. So when we talk about the square root of a number, it's going to be a different number that when you square it gets us back to what we want inside the root. So for example, if we're looking at the square root of 16, we know that 16 can be written as 4 squared. So the square root of 4 squared is 4. Because if we look at it by our definition, when we squared 4, we got 16, which just gets us back to this number. Square root of 25, we can think of this as 5 squared. 5 squared is 25, so the square root of 25 is 5, because it's the number that when we squared it, got us back to our 25. Square root of 81, we can think of it as square root of 9 squared, so it simplifies down to 9. Notice in each of these cases, whatever the squared with the square root, you can think of them as like canceling each other out. So whatever number you had here that was being squared is the simplified version of that root. So two things when we talk about the radical, that's this portion. We talk about the radicand, that's what's inside the radical. So when we simplify these, that 49 is the radicand inside the radical. You want to simplify your radical, so this 3 stays out front. Square root of 49 is 7. 3 times 7, 21. Even though it's not written, that's an implied multiplication. Just like if you have 2x, it's 2 times x. So same thing here, negative 5 times square root of 36 is 6. Negative 5 times 6 is negative 30. When we have two roots getting multiplied, we can just multiply them together and put them under one root. Or we can use this property going the other way. We can break it up into different factors that multiply to that number. So for example, with root 48, it's going to be easier to simplify these down if we make our factor tree first. And remember from the last slide, we want things in squares. So that we can rewrite this as here's a 2 squared, and here's a pair of 2 squared, and then this 3 is by itself. So now if we want to look at it, we can break this up as this is a separate radical, this is a separate one, and this is a separate one. So doing each one at a time, square root of 2 squared is going to give us 2. Square root of 2 squared is going to give us 2. And then we still have the square root of 3 in there. Everything that's on the outside together you can multiply. So we get 4 root 3. 120 works the same way. Start with your factor tree. Here's a pair of 2's. And notice the 3, the 2, and the 5, none of them have another pair to go with. So the square root of 2 squared becomes a 2 on the outside. This 2 times 3 times 5, none of them have any other squares with them. So 2 times 3 is 6, 6 times 5 is 30. (56), start with our factor tree. we've got a pair of 2's, then a 2 and a 7 that are by themselves, to square root of 14. Same idea with all of these, just start with your factor trees. And it doesn't matter which way, I could have just as easily have gotten same numbers this way. Notice in both cases we have 3 2's and 1 3. Negative 8 times 2 is negative 16, times 3 is negative 48, root 2. Now notice with 30 we don't have any pairs at all, so it would just be like 2 times 3 times 5 under that square root, which gets us back to root 30, so that's one that we can't simplify down. So now notice the differences here is we've got a cubed root in all of these. And this last one's a 4th root. So that just means instead of what squared gets us to the number, we're asking what cubed gets us to that number. So it's going to work the same way. Just always start with your factor tree. But now instead of squares, we want cubes. So you want groups of 3. And now we need the cubed roots, so we need groups of 3. So here's a group of cubes, 3 cubed. Here's some 2's. Then we have a 5 and a 3. So the 3 can come outside because the cubed root of 3 cubed is 3. We'll do the same with our 2. Three times 2 is 6. 5 times 3 is 15. Don't forget that it's a cubed root, so you need this little 3 right here. You need that index. It's a 4th root, we need groups of 4. And then we have a 3, and a 2 left. 7 times 2 is 14. 4th root. 2 times 3 is 6. 6 times 3 is 18. And we're done.